figured out, worked on. That part I'm not sure. But if I needed to solve this equation, anybody remember what you do at both sides to solve this guy? Square is close. There's another word that you can use because the x is already squared, but you're in the right direction. You may want to help her? Just square root it. To cancel out this little 2 here, you just take the square root of this side, square root of that side. You have to mark that in just to remind yourself. Again, Unit 10 is saying, hey, remember this one last time. Let's find out in this room, is there anyone in here who needs to take more math after this, or this is it? You don't need to take any more. You need to take another, you need to take another, okay. The others won't have to, okay. What's true is, to take the square root of this guy, the radical sign and the 2, they cancel, leaving just with the x. And whatever radical 2 happens to equal, if we had a calculator, we'd punch it in, it'd probably be like 1 point something, because 1 times 1 is 1, 2 times 2 is 4. The radical 2 has to be some number in between that when you multiply it times itself, will give you the 2. So that's no big deal. That's just good old-fashioned regular old math. They talk about it and do a whole lot of stuff with the 2's, but here's where some math guys ran into an issue. It says mathematicians throughout history have resisted the idea that some equations may not be solvable. They're like, look, there's some ones that can't be solved. No, all of them can be solved. It says, still it makes sense that x squared plus 1 equals 0 cannot be solved because the graph of x plus 1 or y equals x squared plus 1 has no x-intercepts. The x-intercepts are called real solutions. In other words, it makes a parabola that's floating above a line. It's a big U floating above the x-axis. The question is, what happens when you try to solve this? And this is where an important point will come. Hey, Thomas, go ahead and solve for x. Sure, sure. Step 1, you guys can do it along with me, please. We subtract 1 from both sides. That's no big deal. You did that in Algebra 1, maybe in junior high. You wind up with x squared equals negative 1. Then from there, your teacher probably rewrite this part so I don't do 2 things on the same line. The next thing that you're asked to do, okay, I'll ask the question again now. We all comfortable. How are we going to get rid of this, the 2 or the squared on this one?
Square root.
Yeah, square root. No big deal. That part gets to feel familiar. The challenge becomes the following. The square root sign asks the question, what's the number that when I multiply it times itself, what's the number when I multiply it times itself, it would give me the number inside the house? Now, obviously, some students would say, well, obviously it's going to be a 1, because, or rather, negative 1. Negative 1 times negative 1 will give you a negative 1. But again, you guys probably know that negative 1 times negative 1 gives you what? Yeah, a positive 1. Speak for the class, I appreciate that. It gives you a positive 1, so that doesn't work. Someone say, well, it's a well, it can't be a oh, they're like, duh. It's negative 1 times a regular 1. Well, no, that doesn't work either. The square root sign, and I'm going to erase that I put in the box. The square root sign says it has to be the same number times itself to give me the number inside the house. So in the end, what we told students throughout the years is, it turns out you can't take the square root of a negative number, because any number times itself will give you a positive number. Well, in order to solve this problem, and I wish I knew the name, I'd say, and so he or she decided, but I don't know, I'm going to ask Brian, I'm going to ask Tim. They decided, you know what we're going to do? If we just made up an answer, it would help us solve some other problems. This one little snag, we could just put like a little plaster over it, just cover it up. We can keep down the road to solve some other problems. Up to this point, they just stopped. Like, we don't care what's on the other side, we can't solve this one. So here's what they decided. They said, we will just say it equals an imaginary number. And that imaginary number, we'll give it the letter I. But the I stands for imaginary number. And now they're able to keep driving down the road. Whenever they see a negative sign inside of a radical sign, they'll use an I for the negative sign, and whatever the regular number is, we do it normally. So for example, and I'll have you guys write down this answer. Please take the square root of a negative 9. Write down the answer, the square root of negative 9. The good news is that minus sign, we have something for it now. I don't know why I didn't put it in the same color. That may make it easier, the fact that it's a red negative sign. The blue, you just do the number. So let's see if we can get an answer on that one. First, oh, someone say out loud what the answer will be to that one. The square root of -9. I heard the 3 part, and what did you say after the 3? Now, normally you kind of almost want the I in front to show that it's the negative sign that's turned into the I. But it's true because that I is in fact a letter. In the world of math, they will always write the number in front of the letter. And so when you're asked the question, what is I? I is the solution to the math equation, either x squared equals -I or the square root of -I. I mean of -1. All right. That's the first thing they want you to know. You may see something along that line a little bit later today. What do I want to do with that? I want to let you know that when we put it into the quadratic formula, more than likely, whatever number you get here is going to be in the house. Let me do one more so that this one looks more like what you're going to get. See who this is going to make them get stuck. Let's make it the square root of negative. Let's see what they do with this. Square root of -10. Write down an answer for that. Square root of -10. The hint will be don't think too hard. Part of it's going to stay the same. Part of it's going to change. What's true is if you know it, boom, you're done. If you're not done, then you don't know what the little trick will be on this one. Someone who hasn't answered first, and then we'll use other backup. Say what the answer will be. Someone.
I'm not sure, but would it be like 5 square root of 2?
That is a good idea. It's not going to be exactly, but I see where you're going. Somebody want to throw something else out to help her out? Or just on your own, whether you're helping her out or not? Once you see what the answer is, you're like, I'll give you another one. Let me do another one. All right.
5 times 2i.
Okay. Right. The 5 and 2. And I know what's happening. When you get a radical sign, you're supposed to try and break it down. If he gives us a 10, we must be able to break it down. But the trick on this one is, which you're going to see later, if it's not a perfect square, we are going to allow you to leave that number inside of the radical. So I radical 10, or I times radical 10. Let me do one more of those ugly ones, just that way now you can do it with ease. Radical, let's make it a big number. Let's make it a radical 26. Go ahead and write that down, and then we're going to go to the next sheet. If I can find it. Hopefully I can close it. All right, here comes out loud. What is the answer for the radical of -26?
I radical 26.
All right. And so in your problem today, while there are some of these that they might give you that you can kind of break it down. Let's say if this were a 24, there's a way to break it down. I'm going to let you leave it in. That is, either it's a perfect square, have it come out. If it's anything other than a perfect square, 25, 36, 49, and so on, then just leave it inside, and that'll be good enough for me. With that said, let's see if we can get you to the handout that you have. The formula one last time. However you memorize it is good for you. For me, the negative sign in the B makes it a negative boy, it makes it a bad boy. He wasn't sure, he wasn't positive, he wasn't negative whether he's going to go to a house party. That's the roof there. He got to the house party, turns out people were wild and kind of like freakish. Yeah. So he turned out to be a square. A square means he's a good guy. He's not wild and wacky. So the boy was a square. Because of that, he missed out on 4 awesome chicks. 4 awesome chicks. How does the story turn into 4 awesome chicks? They made it have to work because they were wacky and wild. And it turns out the whole party was over at 2 a.m. Bad boy went to party. He was a square. Missed out on 4 awesome chicks. The party's all over 2 a.m. I fear there's other versions of memorizing that, but you need to have that there. All right, let's see. There are 3 on this side. So maybe I'll do the 3 on this side. You guys will be the guinea pig. On this side, we will get to do the second one, choosing the A, B, C. So they get the hard stuff, and then we get the easy stuff. So over there on that side of the room, one of you can lead out and just at least give me the A in this problem. I'm gonna put them over here, B and C. I probably shouldn't even put them in different colors, but I guess for now, we'll see if the red matters. Hey, anybody over here? A. All right, one stolen from you. Look at that, just like that. The A is the term in front of the square term. It's when there's nothing there. It's a 1. All right. B. -10. Yeah. See, as long as you hold out, man, then your answer is going to be waiting for you. There's B. And then C, Oswaldo?
34.
34. And again, whatever the sign is on that guy is what you'll use. Now, one of you over here will wind up doing 2 of them. So let me put my 34. Hopefully you can see why we're not going to do, we're only going to do 2. I'll have you try the first one. I don't know if we need calculators. The numbers are pretty big, so we might need calculators once we get inside that radical. So I'll pass that calculator in just a moment. Second one here, Tesla Jessica, give me A, please. All right. The other person, give me B, please. -4. And anybody can give me C. Yeah. Now, hopefully you feel like, oh, this is kind of cool. I'm in Unit 10. I'm about to get credit for it. And it's some stuff that I've seen before instead of having to learn something brand new. So here's the plan. Here's the plan. Maybe do the small and do the big one. Smaller, big, smaller, big. For our purposes, before the calculator, do 20. And we'll do maybe the one ahead of it behind. So go ahead and plug it in. Here's what should happen at some point. You should probably run into an issue on the inside of that radical at some point. So let me give you a chance to do that. We're only going to do 2 of these. There'll be 3 of these that you'll have to address today. So first time, you get to try it on your own, see if you remember. Second time, for sure, after we correct it, you'll get to see. And just for the record, in case you don't know what you're actually solving for, a quadratic is a parabola. It's the letter U or a rainbow. When you do the quadratic formula, what you're trying to say is, where will that quadratic hit the x-axis? That's what the quadratic formula is all about. Normally we just factor them, but on these problems here at number 20 that we're looking at, if you don't wind up with a negative number inside of the radical, anybody remember the name of the number inside the radical? Once you, all that stuff you're working on under the radical has a name. You can't remember it? I'm going to give it in a second, but no hints first. Starts with the letter D. DI?
Dividend?
Dividend opposed to division, it would be that. For the radical sign, DIS. C. All right. It is called the discriminant. Now that word doesn't mean anything to me either. Like if it meant something, then I'd be like, oh, I remember. But the discriminant. The discriminant should wind up being negative. How can you tell sometimes? If you're trying to factor this, here comes the question, hey, what are 2 numbers that when you multiply them, they give you a +5? But when you add those same 2 numbers, they give you a -4. 2 numbers, you multiply them, give you a +5. When you add those same 2 numbers, you give you -1 and 5 is what you would think, because of course -1 and 5. But when you multiply, they give you a -5. Yeah. And that's why, and then look as closely on everybody's, this probably won't work out. Part of it is going to have a imaginary part to it, because you can't just work it out. Same thing's going to happen up there. All right, I saw a lot of you working it out. Let's see if we can work out part of it so that some can either go like, oh, okay, yeah, that's what I had, or you go like, oh, shoot, that's what's throwing my thing off. So here it goes. And my space is limited. Right over here. Stretch you? No, it's not going to work for me. All right, so here we go. I know the B is a -B, and what I probably should have said, second time, I'm down here. What I probably should have said is, consider the following. Wherever you're supposed to put in the letter, put in a parenthesis initially. And I know you didn't do it. If you didn't do the other one, I'd want you to kind of do that so that when we're plugging in stuff, oh shoot, we can see, dang it. Okay, clearly I'm going to be writing down, I would have written on the back of my thing, we see where it should go. I'm not going to take too much time on these because again, if you write out the formula and plug things in where they should go, to me that's the most important part. If you multiply something that should have been negative or positive, or you should have squared something when you just multiplied times 2, I can easily say, oh, okay, yeah, you put everything in the right spot. When you go back to fix, here's where the area you need to fix them. All right, here comes, where's my b? My b is a -4, -4. A is a 1, C is a 5, and my friend over here, you're a 1? Yeah, you're a 1. By doing that alone, I know, okay, they know the formula, they know how to find ABCs, and they know where to put them. Three very important things. Without plugging it in that first time, it messes up. When it's time to do 21 and 22, maybe next week, we'll have you put in everything where it should go. All right, I'm going to start writing quickly because I need to get past this part, what I consider easy. See if there are any questions. The negative b says, I want the opposite of b, so you're going to be +4 down here, plus or minus. Anybody know what the square of -2 is? I mean, of
16.
Thank you. All right, this is the part that should mess some stuff up.
Is it -20?
Yeah. Good. That -20, that part's important. Why is that part important? He needs to be bigger than this guy here. So that when I do 16 minus 20, I get a negative something. And the way you think of it is -4 times 1 is a -4. -4 times a 5 is a -20. That is the big deal right there. All over 2a. Here comes my 4. Look at yours, see if there's any piece that's broken where you can fix it. And then all over 2. They want us to do more than, they want us to do more than what I'm, well, let's get some help. What is the square root of a -4?
2i.
That's the deal. Then I'm going to put all that. Let's put the 2 here and the I. Now, if that would have been a -5, the I would have come out, the 5 would have stayed trapped. But because it comes out, that part's good. At this point, you are a super student. There is one extra step that you can do at this point, which is a tricky one, where sometimes they say, look, just don't do it. So I'm going to say it. If you see it and go, okay, yeah, I see that. Then in the future, you can do it. If you don't see what I'm about to do, then just don't do it. But it goes like this. If a number comes out of the radical, either with the I trailing, or if the number just came out and something else stayed behind, the rule is this. There are 3 numbers you can look at. Again, at this point, I think I would accept this as the answer. It's the I that's important, and if you get there, you're super. But if you look at all 3 numbers, and all 3 numbers in this little triangle are divisible by the same number, like, oh, maybe 2 can go into it, maybe 5 can go into it, then the rule generally is go ahead and do the division. In other words, 2 goes into 2 on the bottom 1 time, which I shouldn't even write that 1 because it's all going to disappear. 2 goes into 4 2 times. And 2 goes into 2 1 time, leaving just the I. If you took a standardized test, this is, that's not the answer you would see. This is the answer that you would see. Notice the box has what I want you to have. This extra stuff is so that if you see this on a standardized test, you're like, whoa, what happened to the 2 on the bottom? Where'd the 4s go? I need you to at least have heard it 1 time on the standardized test. This is what you would see. For my test, for what you're going to do today, this is what we did on our test a long time ago, the box, and I'm okay with it. If you get to the box and you box it and decide, well, let me see, go down further, I'll have latitude on you. In other words, you'll know exactly whatever. All right, pause, look at it. See if you want to ask something though. There's a piece that we're about to do. Let's do 20, and then I'm going to leave this and go on to degrees and multiplicity and roots and all that stuff. Domain, range, all the stuff that should hurt your brain. These are 3 that I want just are guaranteed. Do me a favor, if you don't have a question on this part, go ahead and do 19. The numbers are bigger than the calculators. I assume the 10 inside, I assume we might need them. I'll send those 2 back, please. And let's see if I can. Like I said, I'll move to. In this section, graphing these guys, polynomial functions, thumbs up. Yeah, I can remember pretty much most of that stuff. Thumbs down, like, nah, I think I got like most of it. And you go like, no, I think I remember like kind of half and half. Show me thumbs, just kind of see. Okay. All right. So we're going to remind you of it. It turns out what they're going to ask you is not that much. So it's not the ones that we're going to do here will be like above and beyond what's there. When you get to where you are, like, oh, okay, I don't want to do that. So let's mess around with it. Tick. What do they need to know? First, we're going to build some of these, but let me just comment on each one of them so that when you see it either in picture form or you have to create the picture, you know what's happening. Each one of these represents the idea that a parenthesis, all right, fine. Each one of these represents the fact that a parenthesis, when you get the factors of, you got a quadratic problem and have all those parentheses next to each other. Sometimes your parenthesis just has a 1. P is linear. And when you're drawing the picture, wherever that point is, you're just, boom, zooming through the x-axis. Okay? So make marks on these, even though it's right there for you. Your brain will, just looking at it, go like, yeah. But if it has to write, oh, okay, maybe there's something to it. The second one, so the first one, the degree is 1. That 1 is never written. The second guy, the degree is 2. He's famous. The first 3 are pretty famous. The fourth one, he wants to be famous, but he's just part of the entourage. So here's the deal. On this guy, degree 2, this is where either at that point it's going to bounce and hit the x line, but it won't go through it. If it's coming up as a rainbow, it'll hit the roof and then bounce back down to the ground. So that's what the 2. 2, of course, is a quadratic. 3, he starts getting a little bit interesting because he has to go up like a roller coaster, down and back up. The question is, how do we make that guy? My hint, sometimes some people will say, this first line only has 1. It's just a single line. This guy, he has 2. This guy has kind of 3 pieces. I don't know that you need to think of it that way, but what we're going to do in a moment on bottom, like we did before, we're going to start with a 1, and we're going to build our way all the way up to a 4. And we can even build a 5 if we need to. So here's what I'm going to do. I'm going to build a 4 from a 1. Because the 4 is famous. It looks like a W. Hopefully you can see 1, 2, 3, 4 kind of pieces to him. But how do we build a 4? To build any of these so that you know what the picture should look like, you always start with a 1 shooting up to the sky. I'm about to build a 4 right now. Okay. You got your 1. The minute you need a 2, you're going to start going to the left. In other words, to get a 2, we're going to be able to make it. And there's a 2. To get a 3, you go the opposite direction. You're still on the left-hand side, always going to the left. There's a 3. And then to get a 4, you go up. If you need a 5, you go back down. You need a 6, you go up. So basically, if you start with a 1 and then start moving to your left, you can build any number degree that you need. So I'm going to finish here with this 4. What letter does a 4 produce? Yeah, it will produce a W. Either it'll be like a regular W like this, or it may be one that's pointing down like this. And I'll ask you, how do we know whether it's up or down? So this is the normal one, the regular green and red W. What would we see in the equation that would tell us that the W would be pointing down?
Was it negative?
At the very beginning of the equation, and we're going to look at one in just a moment, it would be a negative sign. A negative sign just says everything, the normal way you do is just flip it all the way down. More than likely, they won't do the negative. So if you're okay with building this W, you should be okay. Start with a 1, then back up to left, right, left. Okay. Pause. Anybody want to ask anything, say anything about how to build a 4? Do me a favor. Right next door to it, please build a 5. start with a 1 and build a 5. Just so you will have done one on your own. So you're building a 5 right now. And what's important about being able to build a 4 or a 5 is when you are, when you have a problem to work out, and they give you the choices for what the answer will look like, at least you know, oh, okay, oh, that thing looks like a 4, it's a W. So when I look at the answer, I'm looking for something with a degree 4. Or if it's a 3, but you have to kind of know what the picture is going to look like. And I'm going to build mine in just a second. If you did it, of course, it's just one extra line on that W going down, but if that didn't dawn on you, then fine, whatever you did is okay as long as you have that. Here it comes, big enough for me to build, and then we'll go on to the next page now. Alright, so I'm building a 2, a 3, a 4, and then a 5. Any question about building a 5, a 6, a 7, 8? You just keep going to your left. Alright, let's see. This is kind of what flips the page. We'll mark something on here if you have a highlighter. And they talk about end behavior. What I don't remember is if they talk about end behavior on the thing you're going to know. But for now, odd degrees, like the 3s, the 4s, the 5s, they always start low and end high. So I would put a mark like that and then circle the word odd. They start low on the left-hand side and end high. So if it's a 5, I know 5 is going to do something, and something in the middle, and it's going to end high. So let's say this is a 5, or if they did a 7, start low, end high. If it's an even, like a 4, obviously like a 2, this is a 2. But if it was a 4, you know the 4, now obviously we know it's a W, but I'm just trying to make a point that at least you know what it's supposed to look like. If they're even, a 2, 4, 6, 8, all hands are in the sky. Okay? And as Tesla said earlier, and the way they write it is, if A is negative, A represents the very first number at the very beginning, the leading coefficient they call it. If that's negative, then you go from high to low. It kind of flips it. So if you can turn that, I wish I could turn it so you can see it. Over this guy, you can see that this negative points down. Again, I don't think that'll be a big issue this time. I think they're just going to keep it positive because they want to know some other stuff about you. Reminder on how it starts. Now let's fill in all the stuff from long, long time ago. Let's see who remembers what the first question is going to be. And don't say it yet, but think to yourself, or even write down a number if you have a pencil, what the degree is of this one. Don't say it, don't say it. The factored form of it will help you. Even though on the test tonight, I'm going to actually I'm going to offer you the factored form. The work that we need to do to get the version they're going to give you, we'll do that in the future, so at least I can say to whomever, yes, I gave them the factored form, but that's so we can move forward. There you go. Hey, anybody know the degree?
6.
Yeah, this is a 6er. There's this term right there. It's a 6. Do me a favor somewhere. Oh, next to the 6, sketch like a 6. Make a 6. We made a 4 just a second ago. Make a 6. Just so you can feel like, oh, okay. It doesn't matter what the degree is. If I can make a 1, and anybody can make a 1, there's an arrow shooting up in the air, then I got back up to my left and make a 6. The other important part of making a 6 is just when we draw the actual picture, which is part of your task today, drawing the picture once you know the degree. At least I know what it's going to look like. I'll make my 6 while you're doing yours. 1, 2, 3, 4, 5, 6. Now, of course, I make it jagged, but technically it's supposed to be rounded edges, but on the standardized test, they won't have a jagged version and a rounded version for you to choose between. So, Let me skip down to how many solutions there are. Wait, how many solutions? Point it. She's saying something. He's saying something. It turns out it's 6 as well. The solutions, so that you know what they're talking about, is how many times does this picture hit the x-axis? How many zeros? This line, so you can feel why they say 0. This is the ground. From here, you're like, let's say this is a 3 on the y. This is a 2. This is a 1. This is a 0 on the y. So I want to say, hey, what are the zeros? What are the x-intercepts? And then you put in here zeros as well. Roots. They have in both places, so I'll put roots. I'll put zeros. I'll put zeros. And I guess I'll put solutions here. All right. Let's see. Orientation, is this thing positive or negative?
Positive.
Okay, positive. It's automatically positive if you don't see a leading negative. Okay. So again, part of what you're doing today is just a reminder from Unit 7. So those who have good memories, the way they're doing things now get to be good for you. For those whose memory, like, yeah, I can't remember that stuff. All right, there are 3 roots. Let's see what they say. Once you say one, don't say another. Can someone tell me where one of the roots is?
0, 2.
0, 2. That is going to be close.
0, -2.
0, -2. That is, to get the roots is true. It's going to be at the same number but the opposite sign. And just in case you forgot, like, why is it the same number and the opposite sign? Because technically a 0, the question to how to get a 0 is, what number do I need to place in the place of x so that this whole parenthesis will equal 0? Well, it's always going to be the same number, and you just need the signs to be opposite, and then this whole parenthesis will equal 0. So we got a -2, 0. Someone different say another root, please.
0, 3.
Even though, make sure you put that 3 first, because 0, 3 says that you would be on the y-axis. We want you on the ground floor on the x-axis, and of course, the first number is the x. And then the last one, please. Someone different. Oh, thank you. All right. Take a look at those and see if they're weird. I'm trying to get us to do. I won't do too many, but after this big one, we're trying to find some smaller ones for you to just mess around. Just to remind you of. All right. There's this thing called multiplicity. Back in the day, we used 3 words for it. Multiplicity. We're going to say there. There are 3 words that are associated with base law. Anybody remember what those words were for multiplicity?
Single, double, triple.
Single, double, triple. So again, once you say one, don't say another. Someone tell me what do you think the multiplicity will be on the -2? Single, thank you. Someone different. What will the multiplicity be on the 3?
Double.
Double. So they're like, oh, how did I know? I can't even tell. Double, and then someone else. The last one.
Triple.
Thank you. I heard it in both places. Single, double, triple. This, dang, we're near the end of the list. So it's a long list. What's the list? We know they've added a couple of pieces, added domain and range. So I'm going to add that domain and range part in a moment. The single, double, triple tries to tell us when we go through the x-axis. Let's say this was my x-axis. Is it going to go through it straight? That's a single. Is it going to, so I'll put my single here. A double, what would a double look like?
The U where it bounces off.
Will it be a U? And someone else, triple?
W? No.
W, close. The bend is another way to say it. It's kind of like a spaghetti. It's kind of hard to see that one. So yeah, I get it. It is a lot of stuff to remember, which I'm starting to like the idea that they're reviewing at the very end so that when we send you off into the world, it's like, okay, not only have I heard of it, but one last time, all right, got it. All right. So let's see if we can try to draw this picture. Should I try to do it where they remember something? Do this. Start by putting in the roots where they go, the zeros where they go. Put a dot where they go. And then what I want you to try and do is, oh, they want if it's coming up or down. Oh, we'll put in the dots from there. The rest of it will kind of start together. So find -2 on the x-axis. Find a +3 on the x-axis. Find a -5 on the x-axis. The good news is, since I know this is a W, we'll start with the arms at the end, and then we'll figure out what happens on the in-betweens. From there, we'll have you try to do maybe a couple of small ones. All right, let's see. If I'm drawing this picture, I haven't put in my dots yet where the
Do we have
-2.
to know the y-intercept first?
You don't necessarily have to know it first, but at some point, yeah, when it crosses that line, that's going to be important. So maybe let's find that out. Do you remember how to get that y-intercept?
No.
No, 1, 2, 3. And you're a fiber, -5.
Where you had like to add all those things in
Here, so you're on the right track. As Jessica's saying, it has to do with each one of these. That is the number that's inside. We would raise it to the power of the outside exponent. Once we get that, we would multiply the 3 separate answers together, and that would give us the y-intercept. What the y-intercept says is, hey, if I were to put 0 in the place of x on each one of these, and then work it out, what would I get? The y-intercept. So here we go. Let's see if I can kind of demonstrate that. It's too much stuff on one thing. I feel bad about it. But here's what I'm going to do. Someone tell me what 2 to the first power is? 2, so trick question. How about a -3 to the second power?
6.
I know what you think.
Positive.
That +9, I know why the 6 though. And then 5 to the third power?
125.
125. Now, as the stuff is starting to increase, the amount of stuff to remember. Hey, what does Thomas kind of want you to remember initially? How to get those roots. That part's important. Where I'm going to put them on there. And their multiplicity. What is it going to look like when a line goes through it? So right now, the y-intercept, no, it's still semi-important, but some of these things, if you had them without the y-intercept, I'd probably be able to work with you. What is this big number?
2,250.
2,250. And I'll put this as the y-intercept up there. And I'm going to put it down here. I wonder if I should put those numbers down here. I don't know if I put them alone, would a person recognize where they came from? I'll put them in here anyway, and then at least the person will say, hey, where'd you get these numbers? I say, oh, up here, whatever. And they gave us the 2,250. All right, I'm going to start trying to draw the picture, see if you can feel where it's coming from. Because it's a 6, I know it's a wacky W, so I'm going to start coming down. The very first line of the W comes and meets the point that's furthest to the left. In other words, when I come down, I'm coming down through that 5, because he's the furthest point to the left. The question is, can anybody tell me what I'm going to do at that 5?
You curve it up.
So he's a triple, so I'm going to bend him when I go through that 5. Let's see if I can do that.
Does it mean anything that it has to be upside down or no?
That it has to be
A
upside down.
triple sign. Because you know normally you have to start low
Oh, okay.
and high.
If you were making a graph that was degree 3, then it's true, you start low and end high. If you're determining what's going to happen at a point, and it happens to be a triple,
Then you flip it to how it's supposed to fit.
right, it just means it's going to bend there. So if this thing said we have to start up here because it's positive, and we do, then it bends this way. If this were a negative sign, and let's just say we started here, then we'd bend through it. So yeah, you start with whatever the orientation is, and then when you meet your person, like you said, you do whatever it tells you to do. Bounce on it, go straight through it, bend. All right, so I bend through that guy. The real question sometimes people ask, well, how low do you go before you start coming back up to get to that 2? For the purpose of sketching, it's up to you. If a person bent right here and went up, it's fine. All right, even though I should ask somebody who really loves math, hey, how do you really know when you're supposed to turn the corner? Hopefully they tell me no, it's still just a sketch. I'm coming up to 2, someone different. Tell me what's happening at 2. What are we going to do at 2?
You go straight. You go straight up.
Straight through that thing. Now, as we go up, the next thing that would normally happen, we would go to our Y-intercept, because the next number that we're going to do something at is at the 3. You know, something feels weird about that. Oh, I see. Okay, it's a double up. For a second, I was like, how are we going to get back from the 3 going back up? Because I know, since it's a 6, it has to end up high, but fortunately, that 3 is a double. As I told you guys before, technically, if you draw it all the way up to get up to that 2 plane, I'll put mine right here. What if you put yours lower? It doesn't matter. What we're saying is 2, 2, 5, 0. This is the Y-intercept. All right, let's go through that thing. Let's see if we get to some small ones really fast, because you're going to need to get your thing in your hand. But again, 3 of the problems on there are going to represent quadratics, hopefully with the negative. And then just 1 is going to represent this and some stuff about it. So here we go, coming down here. I'm coming down to the 3. What's happening at the 3, someone?
Bounce
Bounces
off.
off.
Bounces off. And voila. So there is a new thing they're going to ask you, the domain of this guy. Can anybody, from whatever knowledge you have about the domain, can anybody say what the domain will be of this?
-5 to 3.
-5 to 3 starts it, and that is a good start. Because of these arrows, it's going to make it do something more than that. Yeah. So, go on.
I feel like it's negative infinity instead of positive infinity.
Right, it is going to be that. So let me start with you with the 5 and the 3, just in case you forgot about domain and range. Domain and range, of course, rather domain, says, hey, if I'm on the x-axis, if I'm just walking back and forth, how far from the left will I start, and how far to the right will I go? That's what the domain says. Well, it kind of makes sense. Yeah, I'd start back here at this -5, and then I'd walk all the way to the 3. That's my domain. But arrows always say, we're going to keep going and going. We're just going to draw the picture so the arrow says it goes on forever. As a matter of fact, if you look here on the x-axis, and on the y, you'll notice it actually has arrows to say that, no, this doesn't stop at 9 or 10. It goes up forever and ever, down forever and ever. So I'm going to write it with the domain. I'm going to write it with, what's the word I'm looking for? With the brackets, domain. The domain, I'll write it 3 ways. We can go from negative infinity, from the left side over here to me, all the way to the positive side, positive infinity. When you deal with those, parentheses mean it doesn't include positive and negative infinity. If it ended at a number like a 5 or a 3, you put those square guys. The other way to say going forever and ever this way and forever and ever that way is all real numbers. I do want you to write these, all real numbers. That way if you see it somewhere, all real numbers is popular. All right, we got 7 minutes to give you guys a chance to do 1 or 2, and then how do you start? All real numbers, and then the other way they write it, just in case you see it. Because math people don't really like writing a whole lot. A special R with double legs is all real numbers, so we can rewrite that. Now, if all 3 of these weren't extra popular, that is, they wouldn't show these on a standardized test, I probably would have only put the one that's popular, but they do all 3 of these. All real numbers they love, that double R they love. All right, so Thomas, we went through the big version. Could you give them a couple of small ones, and then give them 15 minutes to do as much as they can? Yeah, let's see if we can do that. All right, on the little sheet, there's a couple, they won't be super big. Let's see, or should I just have them try that one on the factory? Probably on the back. They speak that one. Yeah. Do that to begin with. No, that's where you're going backwards. Yeah, let's see what you do in about 2 to 3 minutes on the last page. You're going to try and create an equation that goes with this one. Yeah, because these ones have pictures as well. Try and do an equation that goes with this one. And you're basically going to try and put out these items here. In other words, you're going to say what the degree is, the orientation, how many solutions. You can abbreviate some of these things, the D, O, S, R. I mean, you know. So do what you can with this one. My hint on this first one is what letter. In other words, what letter does it look like? And that hopefully will help some of you out. But go ahead and try that, and then I'm going to see if we can look at one or two more baby ones. Our goal is in about 7 minutes to hand out. Oh, that's fine. So we got that. And what's that third root? Now, I also want you guys to notice, though, the roots are exactly the way they appear on the picture. Like, he really is a 0, he really is a 2, he really is a 3. But notice that if you have to write back the original equation, when you put it in factored form, you have to do the opposite signs. So up here, the root 2 means, oh, if I put a 2 in the place of x, it would give me a 0. Or a 3, oh, if I put 3, whatever number follows, oh, it will give me a 0. So that number that follows has to be the opposite. So the roots really are what you see. The factored form, when you write the equation, is going to be the opposite. All right, the 2 is a single, double, triple.
Double.
It's a double. The 0, single, double, triple.
Single.
All right. And we'll get someone else. We usually back up on 3, single, double, triple. Now here's some good news. You won't be asked for all of those. I may have you put them in. That way I can explain why I'm willing to do what I'm going to do for you. And you got to start. Okay. In about 2 minutes. If we don't finish this part, the next time we'll do that. All right. The orientation, of course, since it's pointing out, the orientation is positive. It's pointing down. The orientation would be negative. Did anybody do the Y-intercept? Oh. Yeah. It's 0 because you're kind of looking at it, but then also, no, that's the only reason. This extra number out here messes up, or when you look at the picture. The Y-intercept is where does it cross the Y. Hey, anybody know what the domain is?
Yeah, they're infinity.
Yeah. So by definition, polynomials, unless they stop and say this is a real life example, and it starts here and stops there, it's all real numbers, negative infinity, positive infinity. So let's see, negative infinity to positive infinity, or more popular, all real numbers. The Y-intercept was a 0, 0, comma 0. Look at it because of the time I need you to start it. Anybody have any questions about these to get all these guys here? Like, how can you tell if it's this or that? Or again, you'll notice as we do these, get ready to hand out. So you look at whatever you need to look at one last time. The quadratic formula, that's going to be there. Actually, my recommendation may even be to start with the quadratic formula, but I'll put these out for you. We do a little bit of writing, and then we try and capture it on paper before you forget it. But some of this writing we'll have to go back and start trying to fill in some of this, even if we do some of it together. All right, so let me find this. Let's give them at least 1 minute to take a final. The bad boy, positive, negative, radical b squared minus 4ac on the quadratic formula. Maybe for these, if I had to make a 3, how do I make a 3? I start with a 1, 2, 3. I had to make a 4, 1, 2, 3, 4. About 35 seconds, I'll try and offer it to you. Again, what you're going to see are, you're going to see 3 quadratics. And then you'll see 1 that just speaks to, do you know how to write a polynomial? About 20 seconds, so take a look there. You have the single, double, triple. A double bounces. So if you see anything bounce, or if you see a 2, just know he's not going through like a single. He's not bending through like a triple. He's bouncing out of the way. You see it has 2 pieces. All right. Let's give you what we got. I actually need to. You put your name on the front, then I'm going to encourage you to start on the back. There's some information I can give you to be able to do the front. Oops. I didn't do the range. Yeah. All right, don't worry about the range. Maybe I'll say something about it. If you're a person who knows how to find the range is, the y-axis. You can try and write something. But since I didn't go over it explicitly, you want to guess on it, put a question mark next to it. The front, here's what's happening on the front. Alright, so no, sorry. Put your name. You're going to put HO number 4. Let's know this is handout number 4. Then I'm going to have you flip to the back and begin on the back on. So I put the appropriate information that I need you to have for the front. Here's some information I'm going to give you on the front, which is the factored form of number 1. And by giving the factored form of number 1, essentially I'm giving you the information that you need for number 3. I tossed up in the morning. I'm going to bed at 5 o'clock. So, again, you flip to the back. I'm going to put some information on the front. 2. All right. Let me,
Thomas.
2.
No.
Oh, okay.
You have yours, I got you.
Alright, here we go. So again, put your name, class color, HO on 4. And while you're doing that, I'm going to find the information I'm going to give you for number 1. And once I tell you to write that down, then whether you choose to come back and do those first, since you're familiar. Alright, please write down the following. Next to number 1. Where are they going to write that next number 1 on? You can write it below the, or to the right of the problem. I'm going to take that one off the board in a moment here. So go to number 1 right now. Write down the factored form of that big long problem. I'll come and check. Once you have it, just either raise your hand, show me, say something. Yeah, raise your hand real fast, and that way I'll know when I can take it off. I see 1, 2. So go to problem number 1 and write that down. That's the factored form of that long one. You got it? Got it? Write that down. That's the factored form of that problem. That's the one that you're going to be graphing, not the other one. Got it? Okay. Okay. All right. That's for 1. When you graph it, you put in all our regular information, the degree, orientation, solutions, roots. If you forget one of those things that we just wrote down, ask them which one. Like I say, just put it up here. If you forget what the letters stand for, you can ask me. And if you do all the ones I have on the board, question number 2 asks for a couple of them. You don't have to redo them. You just Again, if I was recommending anything, it'd be anything by giving you one, which is on that false information. Essentially, I'm giving you number 3, which hurts me inside a little bit.